Have you ever asked an AI chatbot a question, only to get an answer that's just bizarrely confident but completely wrong? Well, today we are diving into the technology designed to fix that exact problem. It's called Retrieval-Augmented Generation, or REG for short. We're going to break down how this incredible technique keeps AI honest by connecting it to real, verifiable facts.
We've all seen it happen. An AI states something with absolute certainty, but it's just plain false. This phenomenon is called a hallucination, and it is one of the biggest hurdles in AI right now. So, what's going on here? Why do even the most powerful, most sophisticated models get things so spectacularly wrong?
And believe me, these aren't just little, trivial mistakes. They can have massive, real-world consequences. Take Google's initial demo of its Bard AI. A single incorrect statement it made about the James Webb Space Telescope was a factor in a jaw-dropping $100 billion drop in the company's stock value.
Yeah.
That's the kind of impact we're talking about.
Okay, so the root of the problem is this. Large language models are trained on these massive, but fundamentally static datasets. The best way to think about it is like their entire knowledge comes from a library of books, but they were all printed back in, say, 2022. They know everything in those books, inside and out. But they're totally clueless about current events, brand new scientific discoveries, or even your company's latest internal data. This creates a huge gap between what the AI knows and what's actually happening in the real world, right now.
And this is precisely the problem that RAG was designed to solve. So what is it? Well, probably the simplest and most powerful way to think about RAG is that it gives the AI an open book exam. Instead of forcing it to rely only on what it's already memorized, we're letting it look up the answers in real time.
So how does this open book exam actually work? Well, RAG connects the AI to an external knowledge base. Now, this could be anything, your company's internal wiki, a database of the latest medical research, or even just the live internet. It goes out, it retrieves the facts it needs before it even starts writing an answer. It's basically like giving the AI a custom-made, up-to-the-minute cheat sheet for every single question you ask it.
And the difference here is just stark. A standard LLM is taking that closed book exam. It's relying only on its memory, which, as we've seen, leads to outdated or completely made-up answers. But a RAG-powered LLM, it gets the open book exam. It can access current information, its answers are grounded in solid facts, and, this is a big one, it can actually cite its sources so you can go and check its work.
Okay, so we've covered the what and the why. Now let's get into the how. How does a simple question from a user get transformed into a fully grounded, fact-checked answer?
It's really a five-step dance. First, all those external documents are indexed. This means they get converted into these numerical representations called embeddings. You can think of an embedding as a unique fingerprint for the meaning of a piece of text. These are all stored in a special library called a vector database. Then, when you ask a question, the system searches that database to find the most relevant text. After that, it injects that text directly into your prompt, a process sometimes called prompt stuffing. And finally, the AI generates its answer using both your original question and all of this brand new factual context.
But of course, no technology is a silver bullet. As powerful as RAG is, it has its own set of challenges. So let's take a really balanced look at both the game-changing benefits and some of the potential pitfalls.
The advantages are huge. First and foremost, RAG dramatically cuts down on hallucinations by forcing the model to stick to the facts you give it. It's also incredibly cost-effective. See, instead of constantly retraining a multi-billion parameter model, which costs an absolute fortune, you just update the documents in your knowledge base. This gives the AI access to timely, specialized info and brings a whole new level of transparency with those verifiable sources.
But RAG is not foolproof. It still relies on the LLM's ability to truly understand context. For example, an AI generated this statement. It did it by retrieving information from a book with the title, Barack Hussein Obama, America's First Muslim President. So the system found a factually correct source, the book's title, but it completely missed the rhetorical question mark at the end, and so it misinterpreted the whole thing as a statement of fact.
And there's another major challenge: fragmentation. Imagine you're trying to solve a puzzle, but you're only given one piece at a time. If the complete answer to your question is split up across multiple paragraphs or even different documents, the RAG system might only retrieve one of those pieces, miss the full context, and ultimately come to the wrong conclusion.
So, how do we solve these really tricky problems of misinterpretation and fragmentation? Well, the answer is to evolve RAG with an incredibly powerful tool: graphs.
This, right here, is the next frontier for making AI not just knowledgeable, but truly intelligent.
And I want to be clear, this isn't some niche experimental idea. According to the 2024 Gartner Hype Cycle for AI, knowledge graphs are firmly on the slope of enlightenment. What that means is they've moved beyond the early hype and are now being adopted for serious, real-world applications. The smart money is already here.
The evolution from one to the other is pretty significant. Standard RAG is great at finding text that has a similar vibe or essence, but Graph RAG, which uses these knowledge graphs, understands the deep relationships and connections between ideas. This lets it answer complex questions that require putting together information from multiple places, something standard RAG really struggles with.
And on top of being more accurate, Graph RAG is also wildly more efficient. Research from Microsoft found it needed up to 97% fewer tokens than other methods. And in the world of AI, tokens are money. Fewer tokens means less computation, which directly translates to lower costs. So you are literally getting smarter answers for less money.
So let's put it this way. With Standard RAG, we gave our AI a library it could search. That was a huge step forward. But with Graph RAG, we're actually teaching it how all the books in that library connect to one another. And this leaves us with a truly powerful question. We've given our AI a library. What happens when it finally understands the connections between all the books?